roots and introduce something called imaginary numbers. And with that, we're going to be able to perform some calculations, such as adding, subtracting, and multiplying using imaginary numbers. Now, a lot of times whenever I introduce this lesson for the first time, people kind of put up a little wall and tend to block it out because of the word imaginary. We're not learning about something that is purely fictional here. Imaginary numbers do exist and they are quite useful in the world around us. If you've ever seen a 3D movie, the math behind the movies involves imaginary numbers. Same thing with electricity, deciding speakers, noise canceling headphones. All of those things would not be possible without the use of imaginary numbers. So my job here is just to teach you some of the basics of what imaginary numbers are and be able to perform some basic math calculations with them. Without further ado, what is an imaginary number? An imaginary number is just the result of taking the square root of a negative number. So we've been taking square roots for quite some time. You learned how to take the square root of a number way back when you were in middle school. What we are going to add to that now is just taking the square root of a negative number. So the unit I stands for an imaginary unit. I is just the square root of -1. And you think, well, this is kind of silly because you can't take the square root of a negative number. And if I type in the square root of -1 in my calculator, it's going to give me an error. Yes, your calculator will give you an error, although there are settings on your calculator that you could change to compute imaginary numbers. But what's really, really useful about imaginary numbers is what happens when you square it. So I'm going to take you over to the side here and I want to talk about what happens if you square a square root. So let's take a regular number here, like a square root of 3. What if you take the square root of 3 and you square it? Well, we understand that squares and square roots are opposites of one another. They just cancel out. So the square root of 3 squared is just 3. If you want to check that in your calculator, you're more than welcome to. Same thing if I were to do, let's see, the square root of 7 squared. If you square a square root, they will cancel out and leave you just with 7. Well, the same thing is true even when you're dealing with negatives. The square root of -1 squared. If you square a square root, it cancels out and leaves you just with the number under the radical. So if I is the square root of -1 and you square that, you end up with just -1, which we all know is a real number. This is why imaginary numbers are useful in the world around us. Is the square root itself seems like it can't be done, but when you square those values, you end up with real numbers that can really be computed to calculate things such as electricity and different types of currents. Okay, now how do we look at these? Let's take a look at some examples here. Number 1, square root of 9. Well, we've already done this in previous lessons. The square root of 9 is just 3 because 3 squared is 9. So then what's the square root of -9? It can't be 3 because 3 squared is +9. It can't be -3 either because -3 squared is also +9. So here the square root of -9 would be an imaginary 3. We say 3i. There's no real number that you could square to get a negative, so we say it's an imaginary 3. Example 3, square root of 64. Well, the square root of 64 is 8 because 8 squared is 64. So then what's the square root of -64? It can't be +8 because +8 squared is +64. And it can't be -8 because -8 squared is also +64. That means this is going to be an imaginary 8. 8i. All right, square root of 20. Square root of 20, I don't know the square root of 20 off the top of my head, so I'm going to break it down into the product of two numbers. that I can take the square root of. So I know that 4 times 5 is 20. And even though I don't know the square root of 20, I do know the square root of 4. The square root of 4 is 2, and that leaves the 5 under the radical. So then the square root of negative 20. Well, we've seen in the first row that the square root of negative number just makes it imaginary. So here I'm going to get the exact same answer, but it's going to be 2i square root of 5. It's an imaginary 2. Number 7, square root of 45. I don't know the square root of 45 off the top of my head, but I could break it down into 9 times 5. And even though I don't know the square root of 45, I do know the square root of 9. The square root of 9 is 3. So that would be 3 square root of 5. Likewise, if you have the square root of negative 45, you could think of that as the square root of negative 9 times the square root of 5. And even though I don't know the square root of negative 45, I do know the square root of negative 9 is 3i, and that leaves the 5 inside. So that's what an imaginary number is. Imaginary number is just what you get whenever you try to take the square root of a negative number. Now, what we want to be able to do with imaginary numbers is perform some basic operations. So we're going to go through how to add and how to subtract. Number 1, we've got 3 minus 2i plus 4 plus 7i. Now, as soon as some people look at this problem, they see parentheses and they think, ooh, I need to multiply everything together. But this is not a multiplication problem, it's an addition problem. You're right, however, that typically parentheses indicate some type of multiplication, but in this case, you're not multiplying the two sets of parentheses to each other, although you might look for something to distribute. In the first set of parentheses, there's not a number in the very front. If you could think of it as a 1. Now, if you distribute 1, nothing's going to change. It's going to be 3 minus 2i. Same thing with the second set of parentheses there. There's nothing in the front. You could just think of that as a 1. And if you distribute the 1, again, nothing's going to change. It's still going to be a positive 4, and it's still going to be a positive 7i. Now, as far as what you do with these numbers, it's easy. All you're going to do is combine like terms. 3 is a regular number. 4 is a regular number. You're just going to put them together. 3 plus 4 is 7. Same thing with the imaginary values. You've got a negative 2i here, and you've got a positive 7i here. You're just going to combine like terms. Negative 2 plus 7 is positive 5. So I have 7 plus 5i. That is your final answer. We're going to do the same thing on number 10. Number 10, we have 5 minus 3i minus 2 minus 8i. And again, when people see this problem, they see all the parentheses and they think, oh, I need to multiply everything together. But in this case, you're not multiplying the two sets of parentheses together, you're subtracting them. If you want something to multiply, look in front of the parentheses. In front of the very first one, nothing's written. If you think of it as a 1, if you distribute that 1, 1 times 5 is still 5, and 1 times negative 3i is still negative 3i. The second set of parentheses, same thing. If you need something to multiply, you can think of this as a 1 here. In fact, you can think of it as a negative 1. Now here we do see some changes. Negative 1 times 2 will be negative 2, and negative 1 times negative 8i will be plus 8i. So be really careful with that. Always make sure that you distribute your negative through. From here, easy. All you're going to do is combine like terms. So you're going to put your real numbers together. 5 minus 2 is 3. And put your imaginary numbers together. Negative 3i plus 8i is positive 5i. So we have 3 plus 5i, and that is the final answer. Now, pretty easy as far as adding, subtracting goes. Now we're going to get to multiplying. Notice here your sets of parentheses are a little different. 2 minus 6i times 3 plus 4i. There's nothing in between those sets of parentheses, so here you really are multiplying everything together. This is where you'll use the FOIL process. You'd start by multiplying the first term in each set of parentheses. 2 times 3 is 6. Then you will move to the outside number, and the outside number in the second parenthesis. 2 times 4i is 8i. Then we'll move to the inside terms. 6i times 3 is negative 18i. And then L, the last two terms together. Negative 6i times 4i would be negative 24i squared. Now the I squared is really important, y'all. If you have I times I, you get I squared. Just like when we've multiplied x times x, you end up with x squared. From here, we're going to go through and just combine like terms. There is one really important thing to remember. The first page of this slide, we said I squared. I squared is equal to negative 1. Now, what's negative 24 times negative 1? Positive 24. So I'm going to bring all this down real quick. 8i minus 18i plus 24. If you plug in a negative 1 where that I squared is, negative 1 times negative 24 is positive 24. Now clean this up a little bit. The real numbers go together. 6 plus 24 is 30. And 8 minus 18 is going to be negative 10i. That is our final answer. Okay, let's try another one just like that. Number 12. This is a multiplication problem because you don't have anything in between your sets of parentheses. So we're just going to go through and distribute. 3 times 3 is 9. 3 times 2i is 6i. Negative 2i times 3 is negative 6i. And negative 2i times positive 2i is negative 4i squared, because I times I is I squared. Now remember, I squared is equal to negative 1. So if you imagine plugging that in, minus 4, and replacing that I squared with a negative 1. Negative 4 times negative 1 is a positive 4. So let's carry this down here. This is going to be 9 plus 6i minus 6i plus 4. Now combine like terms. You have real numbers. 9 plus 4 is 13. And then you have your i's. 6i minus 6i. Well, 6 minus 6 is 0, so no more imaginary numbers. We end up with exactly 13. Now what's cool about this last one is the imaginary numbers canceled out. The reason why the imaginary numbers canceled out is the terms that we multiplied together have a very special name. These are called complex conjugates. 3 minus 2i, 3 plus 2i. What we multiplied together was identical except with an opposite sign. That's what a complex conjugate is. Complex conjugate would be a complex number that has the exact same real number, but the imaginary number has an opposite sign. So for example, if you had negative 7 plus 5i, and I said, what's the complex conjugate? The negative 7 would stay the same, but instead of a plus 5i, it would be a minus 5i. That's what complex conjugates are. They have the same real number, but the imaginary number is the opposite sign.